Imagine if we could use naturally grown products, like plants and fruit, to store electricity that charges commonly used electronics, like mobile phones, tablets, laptops, or even electric cars. Now, before we start, make sure you hit the subscribe button. And if you already did, do click on the bell button so that you will not miss out any of our new videos. Researchers from the University of Sydney have done just that, and have developed a method that uses durian and jackfruit waste to create energy stores for rapid electricity charging. School of Chemical and Biomolecular Engineering academic associate Professor Vincent Gomes explains how he and the research team managed to turn the tropical fruits into supercapacitors. How does it work? According to Associate Professor Vincent Gomes, using durian and jackfruit purchased from a market, they converted the fruit's waste portions into supercapacitors that can be used to store electricity efficiently. Using a non-toxic and non-hazardous green engineering method that used heating in water and freeze-drying of the fruit's biomass, the durian and jackfruit were transformed into stable carbon aerogels, an extremely light and porous synthetic material used for a range of applications. Carbon aerogels make great supercapacitors because they are highly porous. They then used the fruit-derived aerogels to make electrodes which we tested for their energy storage properties, which they found to be exceptional. What are supercapacitors? According to Associate Professor Gomes, supercapacitors are like energy reservoirs that dole out energy smoothly. They can quickly store large amounts of energy within a small battery-sized device, and then supply energy to charge electronic devices, such as mobile phones, tablets and laptops, within a few seconds. Compared to batteries, supercapacitors are not only able to charge devices very quickly, but also in orders of magnitude greater charging cycles than conventional devices. Current supercapacitors are made from activated carbon, which are nowhere near as efficient as the ones prepared during this project. So, why durian and jackfruit? Associate Professor Gomes said durian waste was selected based on the excellent template nature provides for making porous aerogels. The durian and jackfruit supercapacitors perform much better than the materials currently in use and are comparable, if not better, than the expensive and exotic graphene-based materials. Durian waste, as a zero-cost substance that the community wants to get rid of urgently due to its repulsive, nauseous smell, is a sustainable source that can transform the waste into a product to substantially reduce the cost of energy storage through their chemical-free, green synthesis protocol. What could this technology be used for? Associate Professor Gomes said that they have reached a point where they must urgently discover and produce ways to create and store energy using sustainably sourced materials that do not contribute to global warming. Confronted with this and the world's rapidly depleting supplies of fossil fuels, naturally derived supercapacitors are leading the way for developing high-efficiency energy storage devices.